Hello guys, and welcome to another video. So we'll be looking at this question now, and it reads: consider the electromagnetic spectrum below and answer the questions that follow. And then we have radio waves, microwaves, infrared, and then A, ultraviolet, B, and gamma rays. Then they say use the table to answer the questions that follow. Excuse me. Firstly, we have the question: define the term photon. And if we define photon, we'll say that it is a energy. It's a packet of energy found in light. Yes, a packet of energy found in light. That is the definition. And yeah, you will give yourself 2 marks for that. Packet of energy found in light is the definition. And then 5.2 says give the names of the electromagnetic radiations A and B. For us to remember this, guys, we have to follow the order, and by now you know that if we answer 5.2, we will say what? We'll say Ronaldo's mother is visiting Uncle Xavier's garden. And we know after radio waves it's microwaves, after microwaves it's infrared, after infrared is what? Visible light. So A is gonna be visible light, and then after visible light it's ultraviolet, after ultraviolet it's what? X-rays, and then after X-rays it's gamma rays. So B is going to be X-rays. That's the answer we are going to give. And yes, for each correct answer you are going to give yourselves 1 mark each for A and B. Now let's go to 5.3. It says for radiation A with a frequency of 2,5 times 10 to the power of 16 hertz, calculate the energy of its photon. And remember, guys, if we are given frequency, we use the formula E is equal to HF, because we know the value of the frequency, and we also know the value of the Planck's constant, which is H. So this is the formula that we'll use because we have been given frequency, and then our E is what we want in this case, and we will substitute the information that we have, and we have H, and H is what? 6,63 times 10 to the power of negative 34. Remember that this is given on your information sheet, data sheet. And our F is given as 2,5 times 10. Okay, let me just fix here. All right, so our H is 6,63 times 10 to the power of negative 34, and our F is 2,5 times 10 to the power of 16. And then you are going to put all of this on the calculator as it is to get your answer. Let's see what we are going to have as our answer. So when I calculate, guys, the answer I'm getting is 1,65. In fact, I'll say 1,66 times 10 to the power of negative 17. And because I'm looking for energy, I must write down my unit, which is going to be what? Joules. Remember, without the unit you're not gonna get the answer correct. It's going to be marked wrong. And how do we mark this? We'll see now. Okay, this is how you mark the formula, you mark the substitution and the final answer. But if there is no unit, then your answer would be wrong. Let's go to 5.4. 5.4 says explain why electromagnetic radiation B is best suitable to scan bones and not radiation A. Okay, guys, so to answer 5.4, we will say that the reason why B has, or rather is suitable to scan bones, is because it has the highest energy, or it has the highest penetrating ability due to it having a higher energy or frequency compared to A. Yes, and that's why it will actually be able to scan the bones and not radiation A. So I'm just gonna write down that answer. Okay, so there's our answer, guys. We'll say that it is because B has the highest penetrating ability than A due to having the largest frequency or energy, and this is how we will mark the So when you mark here, you will mark the part of high penetrating ability, and we'll also mark the part of high frequency or large frequency or energy. Okay, and now we move on to the last question, which is 5.4, and it says we have to calculate the wavelength of radiation B if its photons have an energy of 7.25 times 10 to the power of negative 13 joules. Okay, and every time you see wavelength, you know which formula we are using, right? We are using E is equal to AC over lambda. Let's go. Okay, so this is our formula, guys, and by now we know that H is a constant and so is C. What are we looking for? The wavelength, and we are given E, which is the energy, so we are going to substitute. Our E is going to be 7.25 times 10 to the power of negative 13. This will be equal to our Planck's constant, which is 6.63 times 10 to the power of negative 34, multiplied by our speed of light, which is 3 times 10 to the power of 8, and this will be divided by the wavelength which we are looking for. We'll cross multiply here. We say wavelength times energy, and this is the amount of energy, and that is going to give us 7.25 times 10 to the power of negative 13 lambda is equal to 1 times this speed of light times Planck's constant. So we are going to take this whole thing here, we are taking that and putting it on the calculator as it is, and we'll get our answer there. Okay, when I say Planck's constant times speed of light, the answer I'm getting is, sorry about that, the answer I'm getting is 1.989 times 10 to the power of negative 25. Then I will divide by the coefficient of the wavelength on both sides, which is 7.25 times 10 to the power of negative 13. I have to divide by this on both sides. These are going to cancel. Therefore, my wavelength is going to be equal to, now what I'm going to do, guys, is take all of this. Okay, I want to circle, but it's not working. I'm gonna take all of this and put it on the calculator exactly the way it is. All of this exactly the way it is, put it on the calculator. And when I put this on the calculator, guys, the answer I'm getting is 2.74 times 10 to the power of negative 13. What's my unit for wavelength? It is meters. Okay, and this is how we are going to mark. So guys, we will mark the correct formula, mark the substitution of energy, mark the substitution of both the Planck's and speed of light constant, and mark the final answer. And that concludes our corrections for this particular question. I will see you on the next video, guys. Goodbye.